This is going to be a walkthrough slash discussion of my final project for EdTech 531. This is the Boise State Minecraft server. This is my build, the Marshall Flint Labs. And what we're going to do inside these walls is go through 3 different science, specifically chemistry activities. These would be geared mostly toward a high school science course, although particularly the last one that we'll look at could be done at almost any level because it's one of the basic concepts that is taught, at least in my state, all the way down as low as probably first or second grade, talking about states of matter. So we're going to go through this building, and in terms of the complexity of the ideas and actually the way they would be presented in the curriculum, they're kind of in reverse order, and that's just the way I ended up building it. So that would be one thing I might change going forward. There's a couple other things that I'll discuss that I would do differently if I was doing this again. So we enter the lab, and we're going to walk through. Okay, the first lesson has to do with the concept of thermochemistry and conservation of energy. So in this first room, and this is where on a different server, if I had my own server, I would do this differently. I would put this information probably be presented by NPCs or some combination of signs and NPCs, because this is a lot of reading different signs and trying to keep the flow of things going is a little bit challenging. But what I wanted to do before the students enter the rooms is to give them the information that they will need in order to complete the task. So the idea is, okay, we're going to talk about the law of conservation of energy and thermochemistry. And the task will be to smelt iron ore into iron ingots. And by calculating how much energy it takes to melt a certain amount of iron into an ingot, and then assuming that that energy was all produced 100% by the fuel source, you will use that information to determine how much energy was stored in each of the different types of fuel. So given the basic information here, the mass of each ingot is 24.7 kilograms. Iron has a specific heat of 0.45 joules per gram per degree Celsius. So that's how much energy it takes to raise each gram of the material 1 degree. So we'll use that along with the mass. And then the other factor that we need is what is the change in temperature, because the energy it takes depends on how much you have to change that temperature and how much material there is. So we're going to assume that the iron starts at room temperature, which would be about 25 degrees Celsius, and that iron melts at 1538 degrees Celsius. So that is the temperature range from 25 to 1538. We're going to use that formula. So you're actually changing the temperature by 1513 degrees. So that goes into the formula along with the specific heat and the mass. Okay, and then based on the number of ingots, so that would be for each ingot, and then multiply that value times the number of ingots formed, and we're going to assume that all of the heat absorbed by the metal to raise it is produced by the fuel. So there's no fuel, no energy lost during this process, which is not, really accurate in the real world. But in order to do the calculations for this, especially at this level, we're not going to worry about how much heat gets lost or absorbed to the surroundings. So we go down to the lab, and what I would do is I would divide the students up into groups. And depending on, again, this would be another thing I might adjust along the way, would be to create possibly multiple rooms for each fuel type. We have planks up there. That should be a plank in that item frame. So the first room has sticks as a fuel type, and what you do is you come in here, and there's a dispenser with a switch, and you flip the switch, and it spits out a bunch of iron ingots and some sticks. Okay, so we now have the sticks and iron ingots, which we appear to have lost, but let's assume we got 8 iron ingots and 2 sticks, which is what we should have gotten. There's another iron ingot. And then we go over to the furnace, place your items in the furnace. We'd put these in here. Okay, put all your iron in, put your 2 sticks in. Oh, there's my sticks that I got. Okay, and then it will generate a certain number of iron ingots. And what we actually find out in this first room is that you can't even get 1 iron ingot from 1 stick. So it would take 2 sticks to produce 1 iron ingot, and then the fuel is gone. So in the first room, we'd use those numbers that we got in the sort of the lobby area there to say, all right, how much energy did it take to create 1 iron ingot? And then since it took 2 sticks to produce that single iron ingot, we would divide that number by 2, and that would tell us how much energy was stored in each stick. So the amount of energy it took to create 1 ingot divided by 2, since it was 2 sticks to create that iron ingot, would give us the amount of energy per stick. And then what we would do is we would repeat that process. And so I would do this where each group was assigned a different fuel type. And depending on the size of the class and things, I would come up with some different fuel types as well. And each group would have a technician who was responsible for the actual smelting, and a data recorder who would gather the data, an analyst who would do the calculations, and then possibly like a project manager who would kind of make sure everything was done properly or check the work. And so the next one would be planks. We'd repeat that process, calculate how much energy was stored, and then do that for each of the other types. Wood block. So it goes from sticks, which is the least amount of energy, to plank, which has more energy, this all makes sense too if you think about what the different materials in terms of crafting. 1 wood block produces 4 planks, so it would make sense that the amount of energy stored in a wood block is greater than it would be for a single plank. And the ratio that it comes out to, now obviously these are not accurate in terms of real world, because a block of wood is not going to produce, for example, 4 iron ingots in the real world. It just doesn't have that much energy. And 1 lump of coal is not going to produce 8 iron ingots. It just doesn't work that way. But the concept is here. They can use the formula, and given the information that they were given, they can still come up with real numbers and do the real calculations, even though the practical application of this is not really accurate at all. But so that's the first level. Okay, so then we're going to move on. Here's the next. We're going to go to the next level. Nothing to see here. Okay, so this is on the Minecraft for Education server, and this was actually a place where I built some of the very early versions of some of the activities and that you just saw, as well as a couple of others. So this was actually the first stoichiometry concept. It doesn't really work, but the basic idea where you'd get dispensers with different quantities of crafting materials, and then you'd have to build a certain number of items from that. Then also this was the conservation of energy, where you'd get iron ingots and a fuel, and then have to calculate it. So that was just one type of fuel. And then I expanded that idea in the other build to include different types of fuel, and then calculating the different amounts of energy stored in those types of fuel. This was actually the idea here was that I would give each student a different number of items, and then they would have to come together in different ratios. So it might take 2 kids to do 1 crafting recipe, or 3 kids to do another crafting recipe, depending on the proportions that you need. And the idea is that would be a representation of the way different atoms form bonds. So sometimes an atom can bond with only one other atom. Sometimes atoms can form multiple bonds or multiple types of bonds with different atoms. And so, again, highly kind of way out there in terms of the concept, but the idea being that it takes different groupings of materials to craft different recipes. So, and if I give the kids all different types of stuff, then they would have to figure out, well, I need to meet with you and you in order to make this recipe, but if I met with only one other person, I could make a different recipe, so form a different kind of bond. This was what it called the black box. which is a representation of the experiments that discovered the internal workings of the atom. So getting this whole idea that you can sometimes create a model of things that you can't see. So inside this building is a maze, right? And so what I would have the kids do is try to work out a picture of the maze by walking through the maze, but without being able to see the actual pattern of the maze, as it were, up here. So they'd want to create a bird's eye view by walking through it and creating a map of it. So that was that idea. And then over here we have the states of matter of chickens. So here we have the solid state. Right? You see the chickens are so packed in, they are, kind of slipping by each other, moving around. But the idea, of course, being that in the solid state, they are so close together they can't really move. Although they do, as you see a lot of these chickens, they vibrate in place, but they're locked in place because they're so packed together. Here we have the liquid state where they do have some freedom to move around, but they're still basically on top of each other almost, so not a lot of space to compress them. And then over here we have the gas state where these chickens are running around, and I don't have them speed potioned, but if I speed them up a little bit, you'd get the idea that they can run around a little more quickly. So that represents the gas state. And this actually shows another thing that I would do in addition to the NPCs and the mobs that I couldn't do in the server that I was on previously, is create these barrier or boundary blocks and then deny blocks underneath some of the structures so that the kids couldn't actually break them. And then that, and including the NPCs to give some of the information, would be another thing that I would do. So that that concludes the presentation of my build and my game in this virtual world. I think it was, it was challenging at first to figure out a way to use this world to represent different science concepts. But kind of once I started, there's a lot of different ways I could see this being used in my chemistry class if I had access to Minecraft for all of my students, or really any virtual world. I could do something similar to this. It's just obviously Minecraft has the simplicity of building, even though this was a complex build because of the size and the structure of it. I could have done this a lot more simply, and just like I did on that other server. So there you go. That's the presentation. Hope you enjoyed it. Thank you.
So if you've seen any of my builds, you know that I don't do anything small. So I wanted to do something large. This was based on a picture I saw of sort of an in the water world. So I closed off an area of this ocean. And then one of the things I discovered was that you could use sponges to get rid of some of the water. But there's a lot of water, and it takes a lot of sponges. So this is just to give you some idea of what it took. This is pretty close, I think, to the end of where I finally got all the water. First of all, building these glass walls took a long time, and of course they're glass, which is hard to see underwater, so there were lots of holes where water was coming in, and then lots of places where the water was actually sourced from. So even once I got the entire space completely sealed, getting rid of the water was a huge challenge. I tried lots of different methods, including using lava to turn it to obsidian and things like that. But then I discovered you just have to break out the blocks anyway. So putting in sponges worked, but it took a lot of time to find all the sources. And some of it was just kind of random. You can see here's the other side where I've cleared out most of the sponges, because once the water's gone, you can get rid of the sponges and the water doesn't come back, which is nice. So this is what it looks like, kind of cleaned out. And then this is the beginning of the structure. I wanted to build something like an underwater living space. So there's, see, there he goes. That gets rid of the water. That last little puddle there. And then I had to clean out all of the sponges that are there. So those all had to be broken. This gives you some idea of the scale I was working at to try to build this underwater retreat. And this is just going to move on to another clip to give you a tour of the mostly empty space. Now this is once I've gotten rid of the sponges. Okay, you can see what it looks like now that all the water is gone. I have this very big empty space. The lava, I decided to keep that lava sort of pillar there, and I enclosed the whole thing in glass so that when I put the water back in, it will still be there, and it won't get turned to obsidian. And here's a view of the work in progress. So this will be the entrance, kind of the airlock area here where you would come in. And the first area, there's a couple different ways you can go. The first thing I'll show you is sort of the observation deck here, where you have a glass tunnel, effectively, where you could look down, and you wouldn't be able to see all of this because a lot of this space, when I'm done, will be filled back in with water. I've taken all the water out, but I'm going to put it back. And that fill command that we learned the other night will definitely come in handy when it comes time to put the water back in. Just have to be careful that I don't fill the water in to places I've built things. So moving back up, there's this stone staircases. There's a couple different ways you can go. And the first way I'm going to take you down, actually I'll go down, we'll go down the other way first, will be this glass staircase. And on the sides here, you can see one side has got water now, the other side will have water eventually. So this will, and above will also be water. So this will be totally enclosed in water. Goes down to the bottom of the area. Okay, and then that will be connected to the other pathways that I'm going to show you next. So going back up to the top, we come down the stone staircase, and again the walls to either side will be finished in, and then water will be on the other side. Then we'll have, so that'll all be water there, and then this will be the glass bridge that will cross to get to the lava pillar, which goes from the sky down to the base of this area, and it's now it's enclosed in glass, and then I've surrounded that with a glass spiral staircase leading down to the bottom of the lava pillar, and then that is connected. This again will be water in here, except for the tunnel that leads from the glass staircase. This will all be filled in with water, and then we go up the brick stairs. Water will be there, leading all the way up to this house. Now this house will actually be surrounded by water. So there's going to be an envelope of air, but you can see up here where I've started to fill in where this glass is going across the top. So there'll be water on 3 sides and also above, but the front of the house will be in the air, and the front part of the roof will be in the air. So we can go in. I'll have to fix that door. These windows will have water on the outside, and there'll be sea creatures floating by. This would be the bedroom area, surrounded on 3 sides by water. And then we can move out to this other side, which will be in the air, and we have sort of a little beach and a little pond. Again, above and around will be water, but this area is open. And then there's one more area to show you, which I'll connect to this glass bridge. We go in here, and we have what will be an underwater arboretum, just one tree at the moment, which hasn't really grown yet, with a little water feature, and this will all be water above and beyond. And then on the side, we will have an underwater waterfall. So this glass sort of zigzag shape here will have water above, and there'll be water on the sides, but this grass staircase follows the waterfall down to the bottom, and then we have this underwater waterfall and river. You can see where the water is coming in the sides there, and so we'll take you up just to give you a picture. There's the house, the airlock, the glass bridge. There's the underwater waterfall with the grass staircase, and the brick house in the distance with the lava pillar. And just take it up again to give you the overhead view, where you can see this whole thing will be surrounded by water, and some of those outer glass walls will be broken down. So there you go. There's my big epic underwater build.